Hello and welcome back to elementary algebra. We are talking about multiplication of polynomials today. That would be 5.3. So we have seen that addition and subtraction of polynomials is done if we have like terms. Multiplication doesn't care about like terms. Multiplication is going to be multiplying variables with variables and constants with constants within each term. So last time we said that term consists of a constant and or variable part, and we gave some examples like 3x, x squared, ab over 2, 10, negative 4xy, z cubed. Like all of these are terms. Each one of these is a term. And what we do now is we multiply and use the properties of those exponents, where we add exponents and subtract exponents, depending on what we do with terms. So when you have to multiply, let's say 3x squared times negative 2 x to the 4y, the way we multiply is we multiply constants and we multiply variable parts. And we do those separately. So 3 times negative 2 is negative 6. And now we have x squared times x to the 4th, which is x to the 6, because 2 plus 4 is 6. And we just have this one y that it's hanging around, right? So we split constants on one pile and variable part on the other pile, and then multiply constants times constants and variable part times variable part. So with this, we can multiply terms. Now, when it's written like this in multiplication, it's called factors. But each one of these individually was a term earlier in a polynomial. And we are going to do this with multiple terms. Now, we just have, if you want to call it monomial times monomial, that's fine. Monomial is a polynomial with only one term. So let's take a look at another example of this. So let's say you have 3/4 xy to the 5 times, I don't know, 1/2 ax to the 6, whatever. So again, we do the same thing. There is a constant in front. In this case, both are fractions. That's okay. And then you have the variable part. So come on. Let's go. There we go. So 3/4 times 1/2 we multiply across for fractions. So that's going to be 3/8 when we multiply fractions. And then we take a look at all of the variables that we have. And we have a, x, and a y. So a, there's just one a, right? Nothing to multiply with. And then we have 7 x's, right? 6 plus 1 is 7. And then we have 5 y's, so y to the 5. So we multiply them, number times a number, constant times a constant, and then we deal with the variables. Now, the rule that we are using all the time is that good old rule x to the m times x to the n is x to the m plus n. And that's the rule, as you can see, that has been used in both of these problems. We had 2 plus 4 is 6, because the bases are the same. Both bases were x there, right? So that was there. And then in the second one, you have x to the 1 and 6. So 1 plus 6 gives you 7 on x. Now, obviously, exponents of x do not impact a, do not impact y. It's just x's with x's, a's with a's, b's with b's, and so on. And so that was the basic multiplication. And again, I can say number times a number, and then variable part times the variable part. And I just want to focus one more thing to review before we start working with polynomials, and that is distributive property. And the distributive property has a times b plus c is equal to ab plus ac. So technically, we multiplied a times b and then a times c, keeping the sign, right, the plus that was there in between them. Now, we also said that this distributive property works if you have more than 2 members in a parenthesis. Remember, when I walk in the classroom, right, in the good old times, I distribute exams. That means, let's say 20 students in a classroom, then 20 students will get that exam. Now, this example here, it has 2 students in a classroom, and then exam is given to each student, right? We see that student B gets exam A and student C gets exam A. So that's what the distribution means, and you can see it, that it mimics our everyday life very, very well, because every member of parenthesis gets what's in front of a parenthesis. So if I had, let's say, if I had 4 of these, and then some has plus, some has minus, doesn't matter, I'll just move it here. We are going to go and distribute this A to each member of the parentheses. So we have AB plus AC minus AD plus AE. So each member received A. So these are the basic skills that we need to multiply polynomials. Obviously, multiplication table. If you don't know that, then you have to use the calculator. But in general, you add exponents for the same base, and then all you do is follow the distributive property. So let's start with the first part.
I have a question. We're always going to keep the signs, right?
Yes, signs always stay the same. Well, if this is negative, then all signs change, but we'll see the examples. If the number in here is positive, then all signs stay. If the number is negative, they all of them change, depending on what you have. So we'll see that in examples now. So we have monomial times polynomial, which is technically distribution. So if I have 3x times x squared minus 6x plus 4, we will distribute 3x into every one of the members of the parenthesis. So let's see, try this one on your own, and then I will work it out in 18 seconds. No pressure. Let's take a look. So 3x times x squared is 3x cubed. So 3 has nothing to multiply with. X times x times x, right? That's 3x's, so that's x cubed. Then I have 3 times negative 6 is negative 18. X squared. X times x is x squared. And finally, 3 times 4 is 12 plus 12x. So we distributed, meaning we multiply the term into every term of the parenthesis. Negative 2xy times x minus 9. Again, this is all one unit, one term, monomial, and that needs to multiply into both. So I will give you some time to try, and then you guys can verify your answer when I do it. So these problems should always take like 10 seconds or so, because all we do is we multiply, we distribute the values. So we have negative 2x squared y, because we have x times x is x squared. And then here is that negative times negative makes a positive. So plus 18xy. Negative times negative makes a positive in this case. So you can see that now all of the signs are completely opposite of what the parenthesis had, because we multiplied by a negative in front. So now let's pick up some of these exercises that are listed as the homework in a textbook. So one problem they have here says 6x minus 6 times x squared. Multiplication is commutative. You can flip this around if it's triggering your OCD. It's okay.
I'm sorry, I have a question. So I see in the last example, I see how we have the negative 2x 2y.
X
So the
squared.
plus, right, x squared y plus 18xy. Oh, is that because a negative times a negative is a positive?
Yes.
That way you got the plus? Okay. Plus 18xy. Okay.
All right, so for this problem, we can swap it. right? Multiplication is commutative. And then you do the distribution. Can anyone help me with this one?
It's 6x cubed minus 36x squared.
6x cubed, I agree. Minus?
36x squared.
Why 36?
Minus 6x squared.
Oh, never mind. Sorry.
Yes.
I don't know.
So if there was a 6 here, then yes,
Yeah.
6 times 6.
My bad.
36.
I thought there was 6 there.
So,
I was like looking at it backwards.
All good. All right. So as long as you see that it's a single 6 there. Perfect.
Can you break that down?
I just did.
Well, can you do it again, please?
Oh. So we have x squared times x. 6 has nothing to, well, there's a 1 over here to multiply. So it's 6x cubed. And then we are multiplying x squared times 6. Well, they have nothing in common to multiply. So we just get to write negative 6x squared. There, we just put them on a pile. Because there's nothing to multiply when we go and multiply the second pair.
Okay.
Yay. Oh, I don't know why I erased that. Can leave these ones. Let's take a look at another. These are all, again, from the textbook. Problem 33 says x squared times x squared y minus xy squared. That's in the textbook. What should I write as the answer?
x4y minus xy squared.
Close.
x4y minus x cubed y squared.
So y squared, yes. So this cube was missing. X to the fourth, yes. So x to the fourth y, and that's when we multiply the first one, we see that x squared, so that's 2 plus 2 is equal to 4. And then next time around we have x squared times x, that's 2 plus 1 is 3, and we still have the y that adds to the end. So that would be the answer. Great. And let's make one up. And then we're moving to the binomials. So here we have negative 2ab squared times 3a squared b minus 4ab squared plus 9a minus x, just to make it as annoying as possible. Ah.
God bless you.
Oh, thank you. I feel blessed now. All right, let's see. What do we have?
Negative 6a cubed b cubed
Awesome.
plus 8a squared b to the fourth
Excellent.
minus 18a squared. And then this last part, I think I got this right, plus
Hold on.
2a.
We have to go back to 18 one. What's missing?
B squared.
B squared is missing,
Oh,
yes.
oops.
All right. And then you said plus?
Is it plus? Yeah, plus
Negative times 2.
2ab squared x.
Nice. Just put them on a pile because nothing multiplies, nothing connects there, right? Great.
Would it be wrong if it was written just as x ab squared, or does it have to be ab squared x?
The order doesn't matter because multiplication is commutative, right? That when you write
Right.
2ab squared x, technically what you have is 2 times a times b squared times x, and you can put them in any order you want. So
Okay.
it is okay to put this as 2x ab squared, yes. Or for that matter, literally any order you want. If you really want to mix it up, right? 2b squared xa, right? Anything.
I
Good.
don't know. That computer can be awfully picky.
Yeah, for
That is true.
purposes of my MATLAB, I would use this because A, B, C, D, and then X all the way at the end somewhere, right? That's the only reason why I would write it that way. But it doesn't matter in the eyes of algebra. All of these letters are equally variables, where in calculus we usually use A, B, C for parameters and X, Y, Z as variables. So you would see stuff written this way all the time, where this means a parameter and this means a variable. Those differences will kick in later as you progress through maze of mathematics if you're interested. But as far as your exam goes, I really don't care which order you put it in, right? As long as you have all of the components there, as long as it's positive, because we had negative times negative makes a positive. Technically, what this negative x means is negative 1 times x. So when you have that times negative 2ab squared, you see that negative 1 times negative 2 is positive 2, and then you have your ab squared x. So that's how it turns into a positive, in case that was a tripping point earlier. The next part is binomial times binomial. And binomial is when you have two terms, right, inside the polynomial. So a plus b, it can literally be anything. 3 minus x, 2x plus 7, x squared over 2 plus 5. So literally anything that has two terms is considered a binomial. Now, the formula for this has a special name, but I like learning forms rather than memorizing formulas. Now you guys will figure out what you like better. Technically, what we are learning is a plus b times c plus d, binomial times binomial. So a plus b is a binomial, and that could be changed into x's and y's and t's and r's and all of the other variables with all the numbers and so on. And same goes for the second binomial. It could be literally anything. Now what I care is that I have binomial times binomial. And the way this is done is you distribute a into both, which is what we did so far, right, since the beginning of the class. And then you distribute b into both. So technically you do two distributions. You go with the first one and do the distribution, which means first multiplies into both of the second parenthesis, and then you go to the second one, b, which multiplies into each one of those. So now when I distribute a, I get that ac plus ad. And then I'm distributing b, I get bc plus bd. So when I distribute a, I distribute a into c and d, and here is ac and ad. And then when I'm done with distributing a into each member of the parenthesis, then I go with b, and that's why you have bc and bd, because b has to be distributed to c and d has to be distributed to c. So you can think about, distributing an exam to every student. So student C and student D got the exam. And then maybe I have scrap paper, right? So now scrap paper is given to student C and student D. So we distribute everything to all of the members of the second parenthesis. Now, memorizing the formula, the way it's written, it's really not that great. Now, another thing that students usually use to get through this easier is the acronym FOIL. So, as you know, I'm never in favor of these, but then again, they're visual help to some, so please use it if it makes sense. The reason why I don't like it is also it works only for binomial times binomial. As soon as you change the size of any of these two parentheses and put more or less terms, FOIL doesn't work anymore as the acronym, because it's very specific for this situation when you are multiplying binomials. Now, what does it mean, FOIL? I'm going to color code this now, and we're going to use different colors. So here in black, we're going to have first. That's what F stands for, first. Now look, A and C are first in their parentheses. So that's going to be the black. Then we're going to jump into red. A times D. That's outer. You see how A and D visually are both on the outside of this expression? So outer, meaning, the first and the last. And then I have the next one, let's go blue, B times C. That's inner. And finally, we have L, which stands for last. And that one we can go orange, let's say. So that's last. And last means last. B is last in its parenthesis, and D is last in its parenthesis. So there you got a FOIL. Again, it works only for binomial times binomial, which for most part, yeah, that's exactly what we have usually. But many times you are going to see other cases as well, and the FOIL as acronym doesn't work there. Now, if you never learn it, it's not too much damage, except if, your future teachers are going to say, well, FOIL it, and then you don't know what it means. A lot of people use that in mathematics, right? Teachers and so on. You will even find it in literature, in textbooks and YouTube videos and so on. So, it's kind of good to know what it means, even if you don't plan on using it. I don't like special cases, to be honest with you, when they apply only on one situation. I like generalized rules. So that's why I like better the idea where A is distributed to every member of the second parenthesis, and then B is distributed to each members. And then I understand that I can extend that idea infinitely. If you know that one principle of how this works, then no matter the size of multiplication, you can always deal with it, rather than being locked in one formula. So let's take a look at what this means. So x plus 3 times x minus 6. So this is some of the most frequent stuff you are going to see in pretty much every math course moving on. And as I said, you can either have FOIL in your head, or you can use what I use, which is distribute 3 into both. So, sorry, distribute x into both. So x times x is x squared, and x times negative 6 is negative 6x. And then distribute 3 into both, which is plus 3x minus 18, right? Positive 3 times negative 6 is negative 18. So I distributed x into both, and then I distributed 3 into both, positive 3. And now all I need to do is to collect like terms, right? So these are like terms, and I can add them. So I have x squared minus 3x minus 18, right? There was negative 6x plus 3x. So the negative number is bigger, therefore the answer will be negative. Cool. Now let's see those math skills. 2x plus 4 times 3 minus x. So if you like FOIL, use FOIL. If you like the idea about distributing, use that. All right, there should be plenty of time. So we have 2x distributing to both. That's 6x minus 2x squared, because x times x is x squared. Then we have the red ones, 4 distributed into each, which is plus 12 and minus 4x. Now it is your job for full credit to put this in the descending order of powers, meaning negative 2x squared has to be listed first because x squared is the highest exponent you have. So you list the highest one first, and then all of the terms that have lesser exponent, they go after this. Now we do have 6x minus 4x.
Do we have to do that every time we solve a problem or only when we do these problems?
Every time in mathematics, yes. So the rule stays throughout pre-calculus, calculus. Every time is descending order, and I think my MATLAB will slap you for it if you don't do it.
Okay. So
So
every time we solve one of these problems, it has to be like the problems that we did above, like way above earlier in class. Those have to be in descending order too.
yes, and
Like the yeah. Okay.
and they were, even though over here the power is 6 all combined, and then another 6, and then a 4. I'm just counting how many variables I have, because actually
Okay.
the power on x is how many x's you have, right? X squared means x times x. So you literally have 2x's multiplied. So if I have a term that says x squared y, well, that one is of the order 3 because you have 2x's and a single y. So that one has 3 variables. This one has 2 variables. Therefore, this one is the boss. This one would be listed first because it has the highest degree. We say the degree of the term. Now, all of these more in-depth things you talk in intermediate algebra, but mainly in pre-calculus for those students interested, right, to go there. So I believe that all of our answers prior to this were in good shape. Again, going back here, the degree is 6, degree is 6, degree is 4, and another 4. I have a, 2 b's, and x. That's 4 variables. So technically, this is the same as having x to the 4th. But the previous ones were 6 and 6 and another 4. So it doesn't matter which one you list first because they both have the 6th order, but they have to be before the 2 circled ones, because the circled ones, let's call it a weight, have a weight of 4, right, which is the degree. Does it make sense?
I guess no.
Yes, no.
No, it does not
Well,
make
I
sense.
guess.
It's simply counting. I have 3 variables, 2 variables, 1, descending order. 3
And then
variables.
what happened to the +4?
Where do you mean plus 4?
This 3x in parentheses x2 minus 6x plus 4.
Yeah, he multiplied the 3x plus 4, which got 12x.
Good.
Oh, okay. Thank you.
Perfect.
No.
So every answer that I provided here is always in a descending order of powers, and that's simply counting. You say, okay, I have 3 variables here, x, x, x. I have 2 variables here, x and x, and I have only 1 in here. So this is a good way to represent the answer because the highest number of variables term is first, and then they drop down as you go. Again, over here I have 3 variables. Over here I have 2. So this one is again good in a descending order. And as I said, my MATLAB will remind you of that, so it will become right as you go there and it slaps you, right? It will become second nature to put them in descending order. So here is another one. So let's go with 3xy minus 6 times 1 plus, there we go, 1 plus 2xy squared. So let's see what you guys get with this mess.
That's not allowed until Friday.
All right, so we have the same idea again when we distribute 3xy to both. So how much is 3xy times 1?
3xy.
Perfect. Nothing changes. And then now I have a 3xy times 2xy squared.
6xy to the third.
So positive 6xy to the third. There is one thing that we have to fix here.
What?
X squared.
X squared, good.
X squared. Okay.
Because we have x in a first, and we have x over here. X times x is x squared. And then y
okay.
to the 3. Yes, y cubed is great. All right, and now we have the red ones. Negative 6 times 1 and negative 6 times. So how much is negative 6 times 1?
Negative 6 times 1 is negative 6.
Good. And then negative 6 times 2xy squared.
Would it be negative 12xy squared?
Perfect. Now, are there any like terms? No, no like terms. So we just need to put this in a descending order, and we are done. So if I am to label this 1, 2, 3, and 4, which one has the highest order? Which one has the most variables?
6x squared y to the third.
Correct. How many variables does it have?
2.
Nope.
5.
5.
5. Oh,
We
yeah.
have 2 x's and 3 y's. It has 5 variables. That's why it's listed first. 6x squared y cubed has the 5
Can you
variables.
repeat that last part again?
This term has 5 variables because when you
Oh, okay, I see.
explode it.
So 2 X's and 3 Y's. Okay.
Yes.
Okay.
All right, so which one is next highest?
So when you say descending, you mean from highest to lowest?
Yes.
Okay.
3xy.
How many variables in 3xy?
2.
2. And how many variables in this one?
2.
Ah.
Oh, 3.
Yeah, x, y, y, right?
Uh-huh.
So that's the next one.
Okay.
So we have to look at all of them. We have to look at all of them at the same time and figure out which one has the largest number of variables. And it's just counting, right? So there is nothing more sophisticated, right, going on. It's literally how many individual variables do I have on a pile, and then put the one with the highest first, and then go down from there. If you have same number of variables in couple of terms, like we had in one of those problems, like here, it doesn't matter which one you put first. If I was writing this, you know, for myself, I would put this one first because it's positive, and then the -6 second, because I don't like to start with a negative sign. But again, that's me, it doesn't matter, right? What we have here is a 6 and a 6 and a 4 and a 4. So the two 6s have to be listed first, and it doesn't matter which one is first. And then the two 4s have to be listed second. And again, because they're both 4 in terms of the variables, then each one, it doesn't matter which one is listed.
Okay, when you say count the variables, what you just had circled, can you go back to that? Because I'm actually kind of confused.
You mean this one?
I don't know if you just had that one circled. I think it was the ones above it.
No, this is the one. This is the one
You just
that I
had
am.
circled.
Yeah, but I have 3 A's and 3 B's.
Okay.
So 6 variables.
Okay. So then the second set, the A squared and the B
Yeah.
to the 4. So then that's 2. So that's 6 over
Yep.
there.
Mm-hmm.
Okay. So then the next one would be 4.
Yes.
And then the last one is that, what is that, 3?
It's also 4.
Now, how is that one 4? Oh, because the X.
Yes. So A, B, B, X. So 4.
Okay. All right. So
Cool.
then the descendant order would be the 6. What is it? 6, 6, 4. Is it 2 4s?
Yeah.
Oh, okay.
And that's why I said you can swap these if you want, and you can swap these as you want, because they have the same amount of variables. But you can't swap. You can't put these guys first. They have to be last, but it doesn't matter which one you list first because they're both 4s. Cool. And now to end this lecture, we just have polynomial times polynomial. And that's literally any size of these times whatever other size. So we can start with, let's say, x plus 3 times x cubed plus 2x minus 9, for instance, whatever. And we are going to have the same rule. Take x, distribute into each, and then take 3 and distribute into each. So clearly, the larger the polynomials, more calculations you have to do, but those are all same calculations like before. You just have more of them because the polynomials are larger. So try this one on your own. You have 18 seconds, no pressure. And don't forget to put in descending order, obviously. Okay, let's take a look. So we have x multiplying into everything. What do we get?
X to the fourth
Perfect.
plus. Should I do it in descending order or how I did it first?
No, we have to, well, we're not going to get descending order now because we'll
Okay.
have also the red ones, right?
Yeah. So plus 2x squared
Perfect.
minus 9x
Excellent. And now we're
plus
switching to red ones.
plus 3x cubed
Plus 3x cubed, good.
plus 6x minus 18.
Minus 27.
Oh, oops.
That's okay. Minus 27. All right, so now we have to use the like terms to group those, and we can only group this and this, right? Everything else is different. All right, so descending order. What's first?
X to the fourth.
Perfect. Followed by
3x to the third.
plus 3x to the third. Good. Followed by
2x to the second.
yes, 2x squared. Perfect. 2x to the 2x squared or 2x to the 2. And then
Minus 9x.
well, this is where we use our like terms to
Oh,
combine
okay.
them.
All right.
So minus
So
9 plus
3x.
6 minus 3x.
Minus 3x, yes.
Minus 3x. And then
Minus 27.
minus 27. There it is. So that is one of those. Let's take a look at another one. This one is from the book. And if you don't like it, you just, write a strongly worded email to the publisher or something. Don't complain to me. It's like, I'm just a vessel over here. So,
Okay.
the words are spoken through me. 2y minus 3 times 3y squared minus 2y minus 2. Go. 18, 17, 16. Just to make it worse.
Oh, this is.
All right, so who's going to help me with this problem? What should we do first?
It is 6y cubed
Yes. 6y cubed, 2 times 3 is 6. 1 plus 2 is 3. Good.
minus 4y squared
Minus 4y squared. Good.
minus 4y.
minus 4y. Awesome. Switching to red now.
Minus 9y squared
Yep.
plus 6y
Plus 6y.
plus 6.
Awesome. So now, do we have like terms? We do, right? These are like, and then these are like as well.
So 4y and minus 9y to the second. That'll be 13y to the fourth.
No, y stays the same. So it's negative 13y squared. So we list
Negative.
6y cubed first, and then minus 13y squared. And then what?
Oh. But you're not adding the two together? The two and the two?
No, not when we are adding and subtracting. Only when you are multiplying,
Oh.
you are adding them.
Gotcha.
This is
plus y?
what happened?
No, I was going to the next step.
Okay, what's the next step?
Is it sorry, plus 2y
Awesome. And then?
plus 6?
Yes. Plus 6. That's multiplication, guys. We always distribute. No matter the number of these terms in the first parenthesis, you will multiply, you take the first one, and you multiply it to each member of the second one. Then you move to the next one, multiply into each one, move to the next one, move to the next one. So it doesn't matter how many you have, you will be multiplying using the distribution property throughout the problem. Let's take a 5-minute break. When we come back, we will deal with what we call special products.